Hello, welcome to another section in further maths. Today we'll be talking about factorization and graph of a polynomial function. But before we move further, I would like us to do a quick review of what we had in our last lesson. Okay, welcome back. Now today we'll be talking about this graph of a polynomial. Now I told you something the last time that factorization of polynomial is one unique thing because it controls lots of operation needed in polynomials. Now if you want to draw a sketch of a polynomial, the first thing you need to get is the factors of the polynomial. For example, let's call this example 1. Let's sketch the curve of the polynomial below. Okay, now the first thing we need to do is factorizing it. So I told us how to factorize a polynomial using trial and error method. I'd like us to make use of plus or minus 2. So let's go with 2 first. 12. Which is equal to 0. So we made it of 2. So x minus 2 is a factor. Now let's look for other factors, which include x plus 2 and x plus 3. Now these are the 3 factors of this polynomial. Now we can now use it. If you want to draw the sketch, you know, when we talk about the factors, I said we had x plus 2, x plus 3, and x minus 2 as the 3 factors. So with this, our x point is x is equal to minus 2, 2, and minus 3. So the point of x, if you want to take the coordinate, you know, at this point y is equal 0. So the point interval will now be, the x will now be minus 2, y is 0. The second one is 2, y is 0, and the third one is minus 3, y is 0. And by inputting 0 into the original equation for y, when you input 0, then we now have x as 0. We now have 12 plus 4x minus 3x minus x cubed equals y. When x is 0, we now have this is 0, this 0, this 0, so y is equals 12. That's what happens when x is 0. So we also have another point x and y 12. Now with this point, we are done with it, because if we want to get the line, our line will be of this form. We have 2, 0 and 2. So 2 and 0 will be here, 2 and 0, because this is the x axis. These are x axis, and when you come down here, this is our y axis, so we have minus 2, 0 and minus 3, 0. Now we know that our curve will touch here, here and here, But one of the things we need to check, because this is a straight line and this is a y-axis. Now one of the things we need to check is what is the nature of the curve. Since we have a negative point here, a negative point here, and a positive point here, we continue by evaluating the ranges of x. We now have x at the first point where x is less than minus 3. We have that of b where minus 3 less than x and is less than minus 2. We have the third part where minus 1 is less than x and is less than 2, and we have the last part d where x is greater than 2. Now if you want to take the first check, let's pick a point where x is greater than this. So we now have x to be equal to minus 4 because it's within the interval. So we now have f minus 4. Then substituting into the main equation, we now have 12 plus 4 minus 4. Remember, this is our y. Minus 4 minus 3 minus 4 square minus 4 raised to power 3. And if you do this 12 plus 4, this minus 16, and as this 4 6, which is equal to 12, you can see that our value is greater than 0. Now we do for the next one where one of the numbers is okay. Let's go for f. Since we are looking for a range in between minus 2 and minus 3, so we can go for minus 2.5. Minus 2.5 is within the range, so we now have 12 plus 4 minus 2.5 minus 3 in bracket minus 2.5 raised to power 2 and minus 2.5 raised to power 3. So from the analysis, we now have 12 plus this, which is minus 9. Okay, so minus 5.25 minus 6.8, which is equal to 9 or to over 8. So which is also greater than 0. Now all these values that are greater than 0 will be above the x-axis. Now let's consider the third one, minus 1 and 2. We can take s equals to 0, f equals 0 as one of it, f equals 0 as one of the point, so it's within the interval 2. So we now have, if you impute 0 into here, we have 12 plus 0 plus 0 plus 0, so it's equal to 12. So it's also greater than 0, so this will be found above. And the last one, which is a number that symbolizes x being greater than 2. Let's use x3, so use f and we are using 3, so we have equals, let's go with 3. So this is 12 plus 4 in bracket 3 minus 3 square minus 3 minus 3 this, so this is minus 27 minus 27, this is plus 12, and this is 12, then minus 27 54, which is minus 30, equals to minus 30. So this one is less than 0, so it's only this last point that will be below the x-axis. So in drawing the chart, our graph will be of this nature. Remember our points, which are 2 and 0, the x-axis. We have another point, minus 2. Okay, this is the midpoint. Let's take it that this is the midpoint. So we have another point, which is minus 2 and 0, and we have another point, which is minus 3 and 0. Now our chord will curve here curve here and here. But while we're taking the value, you discover that it was only at this point that we have a number that is minus 30. So this point is the only point that will be below the axis. So the curve and our y here was 0 at point 12. So our curve will now go this way above. Now at this point it will go below, because this point actually got a negative value, while these 2 points had positive values. So they'll be at the top, but this will come from below. So this is the graph. This is the x axis and this is the y axis. So this is the graph of y equals 12 plus 4x minus 3x squared minus x cubed. I think this will enable you to refresh your memory very well on how to draw sketches on polynomials if the need arises, and do well to also use this lesson note on the platform for a better information on the topic we've just discussed. Thank you.